students. I hope you are fine. I am Professor Dr. Shiraz Ahmed, working as course instructor for Basic Electronics for UTEL University, Philippines. Um, the contents which we will be covering today, these are the different types of elements which are present, and then we have the resistor, its types, capacitor and its types, diode and its types, and transistor and its types. And there are various applications where these electronic components are being used in the industry. So basically all the elements which we encounter today in the market, they are divided into three basic categories: conductors, semiconductors, and insulators. So the first thing is conductors. So all those devices which have the capability to conduct electricity, they are known as conductors. All those devices which do not have any sort of capability to conduct electricity through them, they are known as insulators. Whereas there are some devices which have the capability to conduct sometime and or insulate sometime, they are known as semiconductors. Now the examples of conductors, as we can see in the slide as well, they are silver, gold and carbon. In the case of insulators we have like glass and quartz, and in the case of semiconductors we have germanium and silicon. On the y-axis we can see there is a resistivity axis which is representing ohm meter. So according to the conductivity or resistivity, so we can see that the resistivity of insulator is very high, that is starting from 10 power 6 till 10 power 15, and the resistivity of conductors is very less, that is going from 10 power minus 2 till 10 power minus 3. Whereas semiconductors, they are lying between the two, between the conductors and the insulators. So insulators are more as compared to the conductors. Normally in the electronic industry we utilize two devices like germanium and silicon, which are mostly utilized for making of any electronic devices. Now all the electronic circuitry we divide into two categories: passive components and active components. Most of the passive components we are also aware of this, as we normally encounter in the daily life. They can be the resistors, they can be the capacitors, they can be the inductors, they can be the transformers. These are known as the passive components. And passive components are used in conjunction with the active components to form an electronic system. Active components will be the subject of the future courses, like transistors, ICs. These are the active components. Now before going on into the detail of the different semiconductor or electronic components, we must know what is SI fundamental units. SI stands for System International. Now there are some quantities with their units and with their symbols which we normally use in daily life as well as in electronics. Like length, it has a unit: mass, time, electric current, temperature, luminous intensity and amount of substance. Now the length has a unit of meter, and meter is represented by the symbol small m. Mass has the unit of kilogram and the symbol is kg. Time is in seconds s. Electric current is in ampere, represented by capital A. Temperature is in Kelvin or centigrade, but Kelvin is the System International unit. Luminous intensity is candela, represented by CD. The amount of substance is in mole, represented by small mol. Now these were the system components which we normally study in physics. Whereas in the case of electrical units, we have the following electrical and magnetic quantities like current, charge, voltage, resistance and power. Current has a unit ampere represented by A, and it's also represented by I. Charge is in coulomb represented by C. Voltage is in volt or V. Resistance is in ohm, and this symbol is known as omega. Power is in watt or W. Now, scientific and engineering notations. Very large and very small numbers are represented with scientific and engineering notations. For example, we have a number 47 and there are 6 zeros. Either I can represent it as engineering notation, like 47 decimal is after 7 multiplied by 10 power 6. This 6 represents the 6 zeros. Now this is known as engineering notation. Whereas if we have a decimal point after the very first figure, then this is known as scientific notation. So if I shift this 0, this decimal point over here, it will become 10 power 7. So if the decimal number is after one digit, it is scientific notation, but if the decimal number is after the figures, it is the engineering notation. Likewise, see this example, 0 point, there are 4 zeros and 27. So if 0 is moved 5 places, 1, 2, 3, 4 and 5. This is 2.7 multiplied by 10 power 5 scientific notation, and it can be written as 27 10 power minus 6 because the now decimal point has been shifted after 7. So this is engineering notation. As another example, 0.605. As I want to move the decimal 1 point towards right, it will become 6.05 multiplied by 10 power minus 1, and if I move it after the 5, it will be 10 power minus 3, which is the engineering notation. Can you please name the prefixes and their meanings as in engineering metric prefixes? Now this P stands for peta and it is 10 power 15. T is for tera, 10 power 12. G is for giga, 10 power 9. M is for mega, 10 power 6. And K is for kilo, which stands for 10 power 3. In the case of small matrix, small m is for milli, 10 power minus 3. Mu is for micro, 10 power minus 6. N is for nano, 10 power minus 9. P is for pico, 10 power minus 12. And F is for femto or 10 power minus 15. Now coming to the electronic components, what is a resistor? A resistor is a two-terminal passive electronic component. It is an electronic component that limits or regulates the flow of electric current in any electronic circuits. Now these resistors can also be used to provide a specific voltage for an active device, as we have seen that the active devices are transistors and diodes. So resistor is basically a passive electronic component. Now this is the symbol for resistor, and these lines show that the current is being restricted to flow. So this symbol is for resistor, or we also call it as resistance as well. In System International, the unit of resistance is ohms, which is represented by omega, and simple, if the resistance is in small quantities, it is represented by ohm, but if it is a bigger quantity, then it will be represented by K or kilo ohm and M for the mega ohm. There are basically two types of resistors, fixed type resistor and variable type resistor. Now you can see by the diagram that the fixed type resistor has a fixed value and you cannot change it. If you buy it from the market, it has a fixed value, 1 ohm, 2 ohm, 10 ohm, whatever, but it will be fixed. But in many cases there are variable type resistors. You can see there is a variable point. From here we can change its value of resistance and can adjust this value as per our needs. The resistors can be combined into series combination and parallel combination. Now this is a series combination. All the resistors are connected in cascaded and the total resistance is the sum of all these. Whereas this is a parallel combination in which the resistances are in parallel and we follow this formula.